Lesson 5.3, Part B. Alright, now measures of variation are variance and standard deviation. Now this measure is spread because standard deviation measures how far things vary, or deviate rather, from the mean. Okay, but it standardizes it. That's what it calls it. It's called a standard deviation. What is the deviation from the norm? And otherwise the average. Another word is, how does it vary from the average? The only difference in these two is that if you took the standard deviation and squared it, you get variance. So the symbol for standard deviation is this symbol. Okay, and if you squared it, you would get the variance. Okay, all right, so which is sigma. This is called sigma. Here's an example where we have this list of numbers. We want to find the variance and standard deviation. Well, again, we need to know the average because we're talking about how all the data vary from the average. So if you get all the data added up, divide by 8, because there's 8 terms, you get an average of 10.5. Now what it does next is it looks at every number compared to the average. So here's how it would be done by hand. I'll do it a couple of times here to see, but it's a tedious process. That's why we want our calculators to do it, but I'll show you how we do it with a couple of them. I take the data with the point, which is 10, I subtract 10.5 from it, and I get negative 0.5. And then I square it. And that number, okay, since it's negative, okay, it is negative, but since I square it, the negative will disappear and I get 0.25. Then I take the 9 and I say, what's 9 minus 10.5? And that would be a negative 1.5. I square it. And so negative 1.5 squared, of course, so that means you put it in parentheses and square it because it should be a positive, 2.25. And you do that with all the numbers. 10, 9, 6, 9, 18, 4, 8, and 20. And then you would add them up and get a total. And then that sum would be divided by how many terms you have. Again, 8. And that would give you what's called variance. So here's what they do. If they add up, here it is, taking the digit, the term, minus the average, squaring it, adding up all the terms, all the differences, after I square it, divide by 8 terms. So here's the one we just did. Here's the next one we did. Here's the last one on the list, 20. Divide by 8 because there's still 8 terms. I get 27.5. Now that's variance. Okay, so this would say, we don't know what the numbers mean, but it would be 27.5 units squared because we added up squares. If I took the square root of it, like we do here, we get the standard deviation. So the variance is 27.5 units, and the standard deviation is 5.2. Now the smaller the standard deviation, the closer everything is together. The bigger the standard deviation, the more spread out the information is. And that's very important. So if I have a small standard deviation, and I'll use sigma to show that, my data would look very narrow and very close together. That's my normal curve. If I have a large standard deviation, then it looks more like this, more spread out. So the data is not quite so clumped together. And that's the two together. Now our calculator can do this, as I showed you before. We would do stat, calculate, one variable statistics, enter. I did this already and I'll show you again in a minute, but here's what we're going to use for our standard deviation. This is also standard deviation, but it's a little bit different, and if you get into stats class, you'll talk about that. But right now we're just going to focus on this one right here. Okay? So 5.24. Now the calculator gives you standard deviation, so if you want to find out what variance is, you would just take 5.24 and square it, and that would give you the variance. So here we go. We have a list of numbers. we want to find the variance, standard deviation, and range. Now on a calculator, I took the numbers and plugged them in already. If I go stat, now I'll check the list here to show you. List 2 is my list of numbers. Okay, so when I go stat and calculate one variable statistics, so enter, it's already highlighted. Here, I'll do this. Okay, clear the page. Stat, calculate, one variable statistics, second function 2 is list 2. Now if you don't have anything on, if you just have list 1 listed with no other information on any other list, list 1 will be the default. But since I have a list of different numbers here, I want to be specific and say list 2. I go enter, and my standard, here's my average, 350. Okay, well I want standard deviation, which is 50. Alright, the variance is 50 squared. Okay, so standard deviation is 50. Variance is 50 squared. That's how I got 2,500. And the range is the max minus the min. So 425 is the max minus the min of 275, and then 150 represents the range. And that's something not new to us. Next one, put those numbers in my calculator. So again, I'll go stat, edit, list 3 has all those numbers in it. So I go stat, calculate, one variable statistics. Now I want list 3, so that's second function 3. 2.19 or 2.2 represents standard deviation. So 2.1996, if I square that, I get 4.84. So again, 2.2 squared. If I squared 2.1996, that'd be more accurate. And that's how they got 4.84. And again, the range is the max minus the min. In this case, 8.7 minus 1.9. So here's a list of information. We want to find variance, standard deviation, and range. Round to the nearest cent. Now this has units, so this makes more sense. No pun intended. Alright, so $2.29. We enter the data. Okay, so again on my calculator, I want to clear my list here, or clear my screen. If I go stat, edit, if I arrow over to list 4, that's the list of information that they gave us. There's 10 prices. So I'm going to go stat, calculate, one variable statistics, and I want list 4, so second function L4 or 4. Standard deviation, 0.33. Alright, so now round it to the nearest cent, so 0.33 is more accurate. Alright, now 0.33 cents. Variance would be 0.33 squared. Alright, and that would be 0.106. Now that's not 10 cents or 11 cents. That's 11 square cents, or 11 cents squared. And that makes, we don't really talk about cents squared. That doesn't have any, make any sense to us. Alright, so we have to take the square root of that and actually focus on this one. Okay, because 33 cents makes sense to us. But this one, because it's units squared, is not as usable. Range, max minus the min, 1.1 cents. Okay, so $1.10 is our range. Now standard deviation is 33 cents. That's not too bad. It's pretty localized, pretty centralized. Now, how many prices are within one standard deviation? What does that mean? Well, one standard deviation of the mean. Mean is the average. So we're talking about the average, which we found to be, the average was 2.96. That's what it says right here, 2.96. So I would take 2.96 and I would add the standard deviation, and I would also subtract it, and that would give me a window. So that would give me between 2.63 and 3.29. Again, if I add 0.33 and subtract 0.33 from the average. So how many of the numbers in that list are between these two numbers? 7 of them. Okay. What percent of them are within that? Well, there's 10 numbers, so 7 out of 10 is 70%. Now, in finishing, how does changing a data set affect the summary statistics? Well, here's our data list right here. Okay, and I'm going to show you something. We're not going to do it by hand. But if we found the mean, median, now look what they're looking for. Mean, median, mode, range, interquartile range, and standard deviation. It's important to look at these comparisons because we already know that average is affected by outliers and median is not. Okay, so how is everything else affected? Is standard deviation affected by outliers? Standard deviation is, because standard deviation uses the mean in its calculation. So here's the answers. Here are the answers. The mean is 30. The median is 17.5. Mode, there's none. There's nothing more than once. Range is 99. Interquartile range is 49. Standard deviation 30.08. All right, big range there. Mainly because of this. If you looked at that and listed it out, that's pretty much an outlier, if I've ever seen one. All right, well, what if you added 10 to every number? If you add 10 to every number, what happens, do you think? Well, this one becomes 11, 15, 16, 19, 110. All those things are added by 10. Here's the results if you do that. The mean is 40 instead of 30, so that changed by 10. The median was 17.5, now it's 27.5, so that increased by 10. So we just added 10. The mode hasn't changed. The range is still the same because 110 minus 10 is still, I have 1 there. Well, that'd be 11 then. So 110 minus 11 is still 99. Interquartile range, each number increased by 10, so the interquartile range is the same, and the standard deviation is the same. So adding something to every number only affects the mean and median, and it just increases them by 10. What if you multiplied, however, each number by 3? What changes then? So this one would be 3, 15, 18, 27, 300. What does that change? Well, the mean is 90. Okay, so it was 30. We're comparing to the original set now. It was 30, and now it's 90, so they multiplied it by 3. The median is 52.5. If you take 17.5 times 3, you'll get 52.5, so that was changed. The mode hasn't been affected. Range, well, the top number is now 300, the bottom number is now 3. The range did change, 397. Now the range before was 99. If you take that times 3, you get 297, so that everything seems to be multiplied by 3 here. Interquartile range, each number is multiplied by 3, so that range is increased. So 147, the range was 49, so if I take 49 times 3, I get 147. So multiplied by 3. Standard deviation was 30.08. Take that times 3, we get 90.24. So my digits off there. Sorry about that. So adding something only affects mean and median. It just increases it by 10. If we multiply, it changes a lot more things, and it's all a multiple of 3. All right. This ends Lesson 5.3, Part B.